Lesson 36, Confidence Interval Estimation for the Difference in Two Population Means. If the issue under investigation involves the confidence interval estimation for the difference in two population means, we look to the following to help guide us through the process of constructing our confidence interval estimate. Starting with identifying 1 minus alpha, the confidence level. Unless there exists a compelling reason to do so otherwise, confidence interval estimates are constructed using the customary 95% confidence level, or 0.95 decimal. Now, after the random sample data from the first population and the random sample data from the second population have been entered into separate lists, or the sample statistics, x bar 1, sx1, n1, and x bar 2, sx2, and n2 have been determined, the toSamp tint command on the TI-84 calculator will calculate the confidence interval estimate for the difference in two population means, mu1 minus mu2. To do this on the TI-84 calculator, we press Stat to do statistics, arrow over to the menu for tests, and then arrow down till the cursor is next to toSamp tint. Then we press Enter to select. We could either input the actual statistics, which requires us to input the x bar 1, sx1, n1, x bar 2, sx2, and n2. Or we could actually have the actual sample data, which we've entered into two separate lists in the calculator. Here, with the cursor blinking on data, we would press Enter to have the input be data. Then we could down arrow, and for list 1, we denote which list the first sample was entered. For list 2, we would denote the list where we entered the second sample of data. Freq 1, Freq 2 is usually 1 because each sample data comes from one subject. Confidence level is usually our standard 0.95. Pooled is no because we're not learning the pooled approach. And then at Calculate, we could press Enter. Under the toSamp tint command, in parentheses, we'll find our confidence interval, separated with commas. The first number represents the lower limit L, and the second number represents the upper limit U. Now, the formula programmed into the TI-84 calculator is given here. It involves the difference in the two sample means, x bar 1 minus x bar 2, which is the point estimate of the difference in the two population means, mu1 minus mu2. The t times the square root of the sx1 squared over n1 plus sx2 squared over n2 is our margin of error. And adding and subtracting the margin of error to the point estimate produces the interval estimate. Subtracting produces the lower limit L, and adding produces the upper limit U. This confidence interval estimate is constructed using the results of the central limit theorem. Therefore, in order for the normal approximation to be reasonable, either both sample sizes must be sufficiently large, that is, both n1 and n2 have to be greater than 30, or the distribution of both populations from which the random samples were selected must reasonably follow a normal distribution. Now, the confidence interval estimate for the difference in two population means, mu1 minus mu2, is expressed symbolically as L less than mu1 minus mu2 less than U, where the L and U are the calculated values of the confidence interval. The confidence interval estimate for the difference in two population means, mu1 minus mu2, can be expressed verbally, as indicated here, using the actual calculated values of L and U in terms of the issue under investigation. That is, we can use the words of the problem and the actual values of L, U, and the 1 minus alpha to express our confidence interval by saying something like, the difference in two population means, mu1 minus mu2, is estimated to be between the lower limit L and the upper limit U, with 1 minus alpha times 100% confidence. Now, interpreting these confidence intervals, there are different scenarios that can take place. For instance, the first population mean mu1 could be less than the second population mean mu2. So when we estimate the difference between a smaller value minus a bigger value, we end up with a negative difference. So when both L and U result in negative differences, the sample evidence indicates that the first population mean mu1 is less than the second population mean mu2 by as few as L or as much as U. Now, since we didn't conduct a census and we don't know the actual values of the population means, we just have sample results and we have a confidence interval that estimates the values of these population means. The confidence interval for the difference in the two means is telling us that based on this confidence interval estimate, it's estimated that the means could be as close as L units away from each other, or these means can be as far as U units away from each other, or anywhere in between. So here the difference in the two population means, mu1 minus mu2, can be as few as L units away or as much as U units away, with this 1 minus alpha times 100% confidence. Another scenario would be that the first population mean mu1 is greater than the second population mean mu2. And when you take the difference, mu1 minus mu2, we have a bigger value minus a smaller value, which results in a positive difference. So when both L and U result in positive differences, the sample evidence indicates that the first population mean mu1 is greater than the second population mean mu2 by as few as L or as much as U. So again, we use our confidence intervals to estimate the actual values of these population means. The confidence interval that's estimating the difference between these two means is indicating to us that these two means can be possibly as close as L units away from each other. But it's also estimated that the two means could be as far away from each other as U units. Or it's estimated that that could be anywhere from as low as L units away to as much as U units away for the difference between these two means. Another scenario occurs when L results in a negative difference and U results in a positive difference. In this case, the sample evidence indicates that there is no significant difference between the first population mean mu1 and the second population mean mu2. Now, no significant difference means that they are not different, or they could be equal. And if mu1 and mu2 were equal, finding the difference between the same mean minus the same mean results in a 0. And zeros are always between the negative numbers and the positive numbers. So whenever 0 is contained in the confidence interval, the conclusion is that there is no significant difference between these two population means. So now we can try the following examples to help demonstrate how to construct confidence interval estimates for the difference in two population means.